Hey, I'm André, and in this video we are going to recreate this color dust explosion in Unity VFX Graph. This setup has two main parts. The first part is the main explosion, and this explosion particles will guide a second emitter of particles that are essentially the dust particles trails. So let's start. Okay, so let's create a new effect from scratch. Let's delete this one. Right click, create visual effect graph. Let's take this minimal system template and create. Let me call color dust tutorial. Drag into the scene. Here in the inspector, let's reset this and set the Y to 2, so it's not directly on the floor. And let's edit this one. Let me close the other one. And here we have like a minimal particle emitter, right? So in the spawn system here, in this first part, let's add a single burst and let's put the count, set the count to 64. Let me drag this a little bit, and capacity 64, that's fine. Our first particle is there. Let's start by placing our particles inside a sphere. So let's set position, shape, and we select the sphere. So we are going to emit our particles and spawn our particles from a sphere. Let's change the position mode to volume, and the arc sphere, and let's put a tiny radius like 0.01. So this way we are going to make the particles look like they are being emitted from a single point. And let's add our initial velocity here. So set velocity from direction and speed spherical, right? So we have this single burst. Let's add the speed mode to set the to random, and let's say minimum 1.5 and max 4. And here we have the first explosion. Let's add a lifetime, so set lifetime, and let's make this random, not just one. So we click on the block itself, and then we go to the inspector, and we can change here a random from off to uniform, and then we can manipulate these variables here. So let's go from 1 to 4. So different particles will die in different times between 1 and 4. Let's also, in the update stage, let's add a linear drag. So this we actually drag down the movement of the particles, and we can still stick with a strong explosion in the beginning, but this explosion is being eased out. And in the output, let's just, I don't know, maybe the main texture, let's just get the full particle system texture. Let's not use the alpha mode. Let's use opaque and use alpha clipping, and let's say 0.7 something. Then let's use set size to 0.5 or something. So here we go. We have the first explosion, and these particles will be the guide for the dust particles in their trails. By the way, let's not forget to add another block here called orient camera, like face camera plane. This means that because we have these quad particles with a texture, they are not actually spheres, right? So we need to ensure that these quad particles always look to the camera no matter where the camera is, right? So, okay, let's build our trails. The main thing that that we need to understand here is that each particle here, like we have 64 particles, these particles, each one of them need to leave some subparticles, let's say. And to make this happen, in the update particle, we are going to add a new block called trigger event overtime. What this means is that for each 64 particles, we are going to emit one event per second. And we can use this event from this output pin here, EVT. We can do other things based on these events, right? So let's start here with 30 events per second, right? And let's drag this pin here and let's get a GPU event. So from here, we can start to build our response to that event. And let's just create a particle system that will be our sub-particles. Initialize, update, and output. Actually, for the output, let's just like duplicate this one. And just to differentiate them, let's just like, I don't know, maybe set a color, a different color for magenta or something, and a smaller size. So yeah, we have a different particle. Let's crank up this capacity to 5,000. And let's add a set position from source. Yeah, so basically we have our like white particles, our parent particles, leaving subparticles 30 times per second, right? When we set position for each new particle being spawned, when we set from source, it means that in a particular time, let's get the position from our parent particle and let's just place a particle there. So yeah, we have our basic trail. And now we are going to take care of our trail physics. The first thing that I want to do is let's just decrease our particle count, our parent particles, like to 10, so then we can see what's happening. And you can see that I'm resetting the particle system, and we can see always in different positions. To prevent this, and let's make this deterministic, let's go to the game object here in color dust tutorial, and in this inspector, let's like uncheck this reseed on play. So this means that we are always gonna see the same thing every time we trigger the explosion, right? So okay, the first thing that we want to do here, let's get back to the subparticles, the trails. So let's add a position. We already set the position from source, but we also want to add an extra position for that. And let's go to the inspector and random per component. And let's do like minus 0.01 in all axes here, and positive 0.01 in the B slot. So what this does is basically adding some jitter in the particles so they are not super straight. And also let's set a velocity. Set velocity. Same thing, random per component, and let's say minus 0.02 in the first all axis, and the B positive 0.02. So you can see that the particles are starting to leave the trail and move a little bit. Let's call this a trail thickness. So because we are adding some random position and setting a random velocity, we kind of increase the trail thickness. Okay, so in the update, let's move those particles more with the turbulence. They're starting to get crazy, right? Noise type Perlin. Let's change our drag to 0.2, our frequency to 5, octaves to 6, roughness 1. Let's see what's going on. Yeah, nice. You can see that the particles are exploding and the trails are getting thicker and filling this space. This is what we want here. Let's crank the intensity to like 10 for now. Let's make them more agitated. And for now, and let's add another block called gravity. Yeah, not this gravity, like let's say -1 in y-axis. Okay, so it looks a little bit like a fireworks, right? Like a heavy fireworks. So they are exploding, but they are super heavy. And on top of these two forces, let's add a linear drag, like of 10. Basically, will contain everything in place. You feel that the particles are light, not heavy, and they get influenced by the air resistance very quickly. That's the idea here, and they get suspended in the air, right? Cool. Let's get back to 64, and yeah, we have our basic explosion. Okay, now let's polish our visuals. So the first thing that we want to do is to make those particles lit, to respond to light. So we get the output block, right click, convert output to HDRP-lit quad. Yeah, they are already responding to light, right? So we can even turn off our output from parent particles. We don't need to see them, but they are still there. And let's randomize our size a little bit. So click on the size block, random, uniform. Yeah, this is already look cool, right? Let's make half, 0.15 to 0.3. This is already look nicer. Let's also click on the output block, go to the inspector, and check in the frustum culling or an extra optimization and cast shadows. Yeah, so now we can see the particles with more volume, even though they are simple quad circles. Let's also give them a lifetime. So in the initialize block, let's add a new lifetime. You can see what's happening already. Let's add some random value here from 1 to 3. Amazing. And to make this look more natural, we need to decrease the particle size depending on the particle age. We already have our base size. Let's create a multiply size on top of this. And to control this multiplier, let's go to this like blank space, hit space, and then get lifetime, get age over lifetime from 0 to 1. So it's a normalized value. And then we can control the size by sampling a curve. Sample curve. And let's use a curve. Let's like delete this one and get this one. Right click, edit key, times 0, value 1. So you want to start at the top If you want to zoom out with more ease, just type F on the keyboard and you can see the whole curve. And but let's decrease this more, like make a steeper decrease here. Yeah, something like this will work. Don't need to be perfect here. Okay, and let's plug this to the size. Nice. The particles are decreasing their size over lifetime. But now we have a problem. When the particles are exploding, we see clumps at the tips of the trails, right? And this is not a fireworks explosion type. So one thing that we can do to remediate this is actually to make our parent particles to emit less and less particles, subparticles over time. So during their whole life, they are always emitting 30 subparticles per second. We want to decrease that. They already have their lifetime, so we can do like the same thing, get lifetime, get age over lifetime, and also sample a curve. But this time we want to use a curve, a different curve. Let's edit the key, same thing, time 0, value E1, F, we want this type of curve. A aggressive decrease. And this is still going from 0 to 1. Let's multiply this by 30. That is our current number. And yes, let's plug this, and we already can see what's going on. We don't have like those clumps at the tips, right? Yeah, and let's increase this to 100. Yes, this is more dense and look more beautiful, right? And one thing that we can do is expose this as a parameter, so we can like always adjust later. So let's go to the blackboard here. Already click it and hit the plus sign, property, and let's select an int value. We can call this rate and open here and type 100. Drag this here and let's plug this. Let's remove the blackboard. Yeah, nice. It's always good to organize our graphs. Okay, so our next step is to make some dynamics, different dynamics for each trail. So if you see right now, let me pause here. All the trails are like the same, let's say, thickness, and we want to vary this. And but the subparticles don't know exactly they are in a trail or something like this, and we can actually create this data for them. What we can do to create this is actually using a custom attribute, and then we can go to the blackboard, hit plus again, attribute now, and let's create a float. This is a custom attribute that we can call like trail turbulence, because we are going to affect the intensity turbulence for each trail. Okay, we already created this attribute. Let's go in the parent particle system and let's add this custom attribute, trail turbulence, and let's set this here in the parent particle system. And let's create a random value here, let's say from 10 to 30, because our turbulence right now is 10, if I'm not mistaken. Yes, 10. Let's vary this from 10 to 30. We cannot just create a random value for each particle. We want to create this for each trail, and only the parent particles represent each trail, right? So we create this custom attribute for the parent particles, and then we need to read this custom attribute in the child particle system from the parent. So here let's also set a trail turbulence, but this is, let's not confuse this, because this one is for the parent particle system and this one is for the child particle system, right? But in order to pass this value from the parent to the child, we need to actually, outside of the graph, hit space and type trail turbulence, right? Again. But this time location we set to the source. We will actually read this variable value from the parent, and then we are gonna set this to the child. This sounds a little bit confusing, but you can get used to this. Just understand and trust me that you are reading this custom attribute from the parent and propagating this to the child system. And then on the update, remember, we are reading this from the parent on initialize. And then on an update for the turbulence intensity, let's read the value again. So trail turbulence. But this time we want this from location current, not the source anymore. And then we plug this to the intensity. Yes, so what's going on? Yes, we have a different dynamics for each trail. Some trails are more dynamic in terms of motion. They move more, and some other trails move less. You can see the difference even more if we, let's say, put this to like 5 and 50. We can see a lot of different. I think 50 is too much. Let's say 1 and 10, for example. Yes, this we can see exactly what's going on. Some trails are thinner and other are thicker because we are manipulating their turbulence. I'm going to stick with like 10 and 20 for now. Now the particles are disappearing too fast. Let's crank up the lifetime from, let's say, 2 to 10 seconds. So we can see they're more time in the air before they die. You can see we need to decrease the turbulence over time as well, because they are still moving a lot. So we want to decrease this movement over time. So we can just create this, like the same method that we've been using. Get lifetime, get age over lifetime. And let's just, again, sample a curve. A curve like, actually, I think we already have a curve like this. Yeah, this curve will feed us. Let's use this one. And then, okay, so we want something to diminish over time, the intensity that we get from this trail turbulence. So we just need to multiply them. Multiply. And let me organize this a little bit. Okay, B, and then we plug this here. Yes, so because the particles are lighter and they are like being influenced with the air resistance, we don't want them to move a lot more after some time. I can see that at some point they stop it too much, like too fast. We cannot manipulate this curve, but one thing that we can also do is to start more aggressive. Like instead of 10 to 50, we can to 20. We can go from 10 to 50, so we can see a little bit more of their movement, and then we can see the gravity taking over. Yes, then we have it. This is basically the effect that we want. Now we can even re-enable the reseed on play in the spectre. Reseed on play, so we can see like different bursts. Always cool to see. So far so good, but we want to crank up those values, right? We want to see a lot more particles. We've been under 5,000 limit. Let's push this to 1 million. But even that we increase our capacity, nothing has changed because we need to spawn more particles. So let's crank up this to 200 and capacity to 200. Yeah, so we can see more trails, 200 trails, right? Also, we need to emit more particles per time. Right now, we have like 100. Let's crank up this to 8,000. This is a lot, right? But it didn't change because we need to adjust one thing. We have a limit here in the trigger event block. We need to uncheck this clamp to 1, so we can definitely run 8,000. So we have a way more, much more particles right now, and we definitely want to decrease their size. So let's say something like 0.04 to 0.08. Yes, nice. Let's adjust this to 0.6 as well. And zero smoothness. And why not? We can like make the sparkles a little bit more lit. And one thing that we can do, like to make the particles look more like volumetric, you can see that although we already have shadows enabled, the particles doesn't look like spheres. So there's a very cool trick to make billboards to look like spheres. And we can just go over here in the output particle for our subsystem, of course. And in the inspector, you can turn on the normal bending. Right, let me run again. And pause here. And then we have a new slider here called normal bending factor, and we can crank up to 1. Like, it's not a solution for all cases, but you can see the difference here, right? So definitely we have more, yes, this group here, we can see the difference. So yeah, they look more like spheres. Oh, I noticed a little bug here. When they stop here and continue here. Yes, definitely this is a bug of capacity. So we actually need more than 1 million particles. Let's crank this up to 1.5 million. I think this is working now. Yeah, all the trails are there. Yeah, and that's the final effect. We have 2 systems basically, one explosion and one trails. The trails are being guided by the parent explosion. Yeah, and we can keep it lighter or push the particle count higher or a more dense or more detailed result. If you have any questions or any suggestions, leave a comment. If you want more tutorials like this, consider subscribing. Thank you.